let's come down and just analyze this third cell. Okay, what do we mean by that Fn? Now you would have gotten catch to that, idea of that. F means what? Both sides are not matching. Yes, no, not matching, hence here it is a false. And now here we are predicting about no, that is the doctor has predicted it as a no, negative to that respective disease X. It forms Fn. How many? 30. There are 30 such patients. Okay, there are 30 such patients. Means what? Out of this 100 sample that we have considered, there are 30 such patients. Actually, they are affected by this disease, but the doctor is saying no, I don't think so, that the disease, they are holding that respective disease X. So therefore there are 30 such patients. So we call it as a false negative. Means it is predicted as negative by the doctor, but it is false. It is not true, because actually they are, and what you are saying is no, and that's why whatever you are saying is false. What you are trying to say, it is negative, but it is false, because in actuality, in reality, it is yes. I hope now you are going to, you are trying to get the point what I am trying to say. The next one, it's a pretty easy now. The fourth cell, you can understand it. See, both the sides are matching. The actual yes and predicted yes, both are yes, so it's true, and it is regarding the positivity with respect to your disease X. Yes, it is positive. Means what? Actually, there are some 10 samples or 10 patients which are holding the disease. Added to that, what we can say, for those same 10 patients or records, doctor is also saying that yes, I also think that the patients are affected by this disease X, and that forms to be 10. That forms to be 10. Now let's see what these figures come out to be. If we just, if we just see it, actual yes, 30 plus 10, 40 means what? What do we mean by this respective figure? This is pretty easy. 40. In actuality, in reality, out of these 100 samples, there are 40 such patients which are actually suffering from this disease X. Yes, they are positive to this respective disease X. Okay, I hope you got this point. So this is clear. Now what do you mean by the 70 and 30? It's pretty easy. It's from the predictive perspective, from doctor's perspective. If you see, no, that means 40 plus 30, 70 means what? There are 70. Okay, out of the 100 patients that went to the doctor has predicted 70 of them as no, you are not having any kind of a disease. Okay, and out of those 100 patients, 30 is being predicted as yes, you are positive to that respective, yes, you are positive to that respective disease X, and that's what this confusion matrix says it all. Okay, I have just highlighted these two cells saying TN and TP, very important. What we should interpret from this, see, whenever we are working on machine learning, we are trying to train our model. Let's say the model is trained, the model has predicted some of the things, okay, and based on that we have derived the confusion matrix. Okay, now in that confusion matrix for our respective trained model, these both entities or both these cells or both these elements TN and TP should be as high as possible. The count I am talking here, it should be as high as possible. Means what? In our original data set, there will be some yes and no. That is what we say is as a actual no and yes. Yeah, real no and yes. Okay, that is in our data set, and whatever our model will be predicting, okay, doctor is nothing but the model, machine learning model that we have trained, and it will be predicting some no and yes. So what we want, the predictions should be accurate, more enough, it should be very accurate. Means what? If in actuality it is yes, the model should say yes. If in actuality if it is saying no, from the data set, if we see for a particular sample, if it is said as a no, then the label from the model side should also come as a no for that respective sample, and that's what we can achieve by empowering these two respective elements. Means true, you can see just true, you can see this true. True means what? Both the sides are matching. Okay, and that shows that how accurate your model is, and that's what we can just calculate it from here, accuracy. So whenever we are talking about the accuracy of our model, we are considering these two things. The true things. So that becomes TP and TN. Means we are considering all or combining all the true things divided by the total. So what is the true? 10. Okay, it is TP 10, TN40, that becomes 50. 50 divided by 100, that is coming 0.5, and that's what the accuracy is in this just case, a sample case. Okay, so that's how you are considering this thing. The next thing, or the other part of the story about our machine learning model, is about error rate, the error that we are considering. Okay, and it depends upon these two factors, and we have to try to keep them as low as possible. We want it that these two entities should be as low as possible, because what these two situations are trying to tell, data set is saying yes but model is saying no. One case, data set is saying no and the model is saying yes, means there is yes no, no yes. Okay, and that's why we are placing a false here. In the previous case, what was there? No no, yes yes, that was the thing that we wanted, but here this is the unwanted stuff, and therefore it's good to have less as possible, less unwanted stuff here. Okay, and this is actually trying to contribute to calculate the error rate, that is fp plus fn divided by the total, that comes to be 0.5. You can just see 20 plus 30, 50, 50 by 100, 0.5, or you can do it as 1 minus accuracy itself. 1 minus accuracy, you will get the same thing. Okay, then we are talking about the two important things, precision and recall. See, a very funny thing here, numerator is same. Okay, if you have to calculate precision and recall from this confusion matrix considered, you can see in precision recall numerator is same, that is true positive. That means what? This entity, true positive, it is the same thing, but the denominator has changed. In precision, we are more focused on predicted yes. What do you mean by that? We are more focused on this figure, predicted yes. You can see predicted yes. And when we are talking about recall, then we are talking or focusing on actual yes rather than predicted yes. So where is actual yes? Here it is, actual yes. So let's calculate. Figures are in front of us. TP is 10 divided by predicted yes. There are total 30 such predictions, and that comes to be 0.33 something. And then recall, when we are trying to consider the recall, TP by actual yes, that is 10, the numerator is common. Okay, that means the same TP, true positive, we are considering, and actual yes is contributing 40 samples, so therefore it is 0.25 that we have calculated. So that's it guys from my side. I hope this video was enough to clear all the confusions regarding confusion matrix. If you like this video, do like and share with your friends. Thanks a lot friends for watching this video.